I welcome you to my another video about multimeters. Today we will have a look at these. In my left hand, Fluke 87V Max, and in my right hand, Hioki DT4282. Fluke is generally considered to be the industrial standard, the etalon of a multimeter as it should be. Is this claim rightful? We'll be finding an answer to this question during this video. This review will be done as my usual style is. I run quite a big Czech YouTube channel where I test some instruments and equipment and power tools and such, and some topics that are worthy. They make it so high that they also come as an English video. For example, I have just ended my 3 years work on test of 115 DC to DC converters, and I already have published a 57 page of my publication, and also 2 videos from the test, from ripple test and from efficiency test. They are already out on my Czech channel, and I'm currently translating it to English, so you will have it too. Anyway, back to the topic. I have been filling in this table where I store all reviewed multimeters and their parameters, so anyone could find one particular info just at any time. Link to this table is in the video description. There isn't so many multimeters because I have separate tables for low-end multimeters, for scope meters, and mid-end to high-end multimeters. The table is available for download in the video description, so if you have 2 monitors, you are free to put the table on the second monitor. You can also use the table to quickly look up for any info later. How do I evaluate multimeters? I mostly focus on aspects that have major influence on convenience of use. Convenience of use is the aspect that matters, as if you would have 2 different multimeters. You would sooner or later stick to the one that has the best continuity test, that measures voltage the fastest, the way the functions are implemented, if it's good or bad. These things are most important if you have a multimeter for daily use. Your priorities may be the same or even slightly different from mine. To give you a context, my use of multimeters is both professional and both hobby. It's quite wide use of multimeters, but it's limited to clamp meters and classic handheld multimeters. I don't use table multimeters because, well, I don't have much room in here. Now, what are these? Fluke 87V Max is practically the same as Fluke 28.2. Well, at the beginning there was Fluke 87 in, guess the year. It ain't that hard. Then Fluke kept facelifting the Fluke 87 and finally came to Fluke 87V, and the V is Roman 5, so most probably, so it's Fluke 87 Roman 5. Then came Fluke 28.2, that is just another facelift, huge facelift of 87V, but they just made it more rugged. And then came Fluke 87V Max, which is the same as Fluke 28.2. And also there is version for explosive environment and also version for automotive. The only difference, at least from what I know and what we have figured out with sales rep, is the fact that Max variant is more rugged. It has backlit buttons and different batteries and reworked PCB, while keeping exactly the same functionality as 87V. Oh, the backlit buttons also have phosphorus in them, so they glow in the dark. Fluke 87V Max was brought to me by my fan on my primary Czech channel, so let's thank him this way. He didn't want his name to be mentioned though, as one of his colleagues is sort of Fluke fanatic, and he also watches my channel, my primary channel. So it's just anonymous fun with a Fluke. Hioki DT4282 came out in 2013. It's the same generation as previously reviewed DT4256. There is also newer generation of Hiokis, for example this DT4261 that we have already reviewed, or there is also CM4141-50, which I will be reviewing in the future when I get enough footage from distribution rooms. The DT4282, it may be older, but it's still the highest Hioki can offer, so even being 10 years old, it's still actual, still has many things to offer, even compared to other brands today. Hioki DT4282 was brought to me by Teste company. That is also the official Hioki distributor for Czech Republic and for Slovakia. They also had a stand at the biggest Czech industrial exhibition fair, Ampere. There is no money involved in this, we just have a signed paper so that I wouldn't take the multimeter and jump in a submarine and flee to Argentina or something else. That's all. no money involved. To understand the price one has to pay for these, let's see what we have here, because I have already seen many comments talking about these meters being just over expensive junk, which is not true. Well, partly. These are entry-level multimeters. They are the bare functional minimum, the minimum amount of parts so it could be at least turned on. They are like your first multimeter, just the stuff for teenagers and for if you need to measure a battery once in a month. Their reliability is questionable and there is no additional functionality implemented. Safety here is often non-existent, so they shouldn't be used at voltages above 24 volts. These multimeters are like, if they work, then good. That's all. The second group is low-end multimeters. They usually offer some extra basic functions like auto range, hold, rel, max-min, backlight and such. In this category, the implementation of present functions should be adequate for almost everyday DIY hobby jobs. They also implement some basic safety features like having both current ranges fused so they won't explode if you attempt to measure how many amps is there in the wall outlet. They also usually have a PTC so you won't kill them measuring ohms in a socket. They usually leave a lot to be desired but can serve well for decades. The third group is higher or low end. They are usually good enough for daily work in rather safer environments, so even for professionals, but more on the basic side. Here we get good safety features including some more powerful fuses, high voltage protection, sturdy body so it would withstand some fall, and practically all the present functions should be implemented very well. They may be considered the golden middle, being the ones suitable for most of the people. Fourth group, I apologize here, I have only two multimeters there. These are mid-end. They are more expensive and their safety and reliability has been greatly enhanced compared to the cheaper ones. They also usually have some extra fancy functions like these two, who can measure the HD. Fifth group is high-end. These multimeters get the best safety and the best reliability one can usually reach. On top of that, high-ends are accurate as hell and every single fundamental function must be implemented perfectly. There is no excuse for being not perfect in fundamentals, and there is also no excuse for not being above average in the all other aspects. If you get a high end, you expect superiority, and that's how this review will be done and how it will be different from my other reviews. These are just expensive stuff and they must slay. If I was reviewing some low ends, then yeah, some fundamentals could be worse and some additional functions could be pretty shitty, and still I wouldn't consider it to be the killer features. But here in the high-end world, every step sideways, every mistake will be remembered, and if there was a problem with fundamental function being implemented poorly, then the multimeter is officially bad. So in this review, there are no excuses. These guys are expected to master everything, and my expectations are even higher considering that the Fluke 87 series is commonly said to be the industry standard, the multimeter you need for professional work, and many people keep recommending them for demanding applications, and moreover it's quite expensive compared to the Hioki, so we will see how these two can handle it. Now we're gonna compare the accessories. It will however be a little tricky as I possess too little of the leads and clips sort of stuff in order to compare what is comparable. Fluke is sold in many packages. You may get the textile pouch, you may get these Fluke modulars, or these TL175 leads, or anything else, literally. Oh, and with Fluke you always get K-probe. This is for Fluke 87V Max, and this I got with my Fluke 17B+. They are very similar. With Hioki you get their basic leads. Well, basic, they are gold plated, which Fluke is not. Bare minimum Fluke package usually costs around $900 to $950 including tax. Of course in your country it may be absolutely different, and it will be. The Hioki package costs just below $600 including tax. Tax is 21% here in Czech Republic. Now let's begin comparing. Fluke TL175/Pomona 7519A can be bought in some bundles with a multimeter, or they are sold separately for approximately $58 including tax. Hioki L9300, you will get them automatically with newer generation Hioki multimeters, or they are sold separately for approximately $50. To begin, banana. Both have insulation shrouding. Hioki has insulation tip on the banana, while Fluke has not. There is no excuse for that, as even my $8 AliExpress silicone leads and even these very cheap Unity leads that came with my 61E Plus, they too have the insulation tip. Come on, Pomona. The area that you grab, Hioki has the area rubberized with 6 protrusions for even better grip on the rubber. Fluke has this part made of plastic, classic plastic. The red part is plastic. The rubber actually begins here, it's the black part. The plastic is super slippery and quite rounded. Now, Hioki on Hioki. Beautiful. Hioki in Fluke. Beautiful. If I would press it more, then I would break my fingers. Yeah, definitely. So Hioki, great. Fluke on Fluke. Shit. Ah. Once more, let's insert it here. Well, it's more stiff, but guess what? If you press it, if you would have oily fingers or anything, it would be greasy. For example, if you work in a harsh environment around your automobile, for example, you will have greasy fingers, of course, that 5W50 sort of stuff. And this, you won't be able to unplug your probe from your multimeter. Let's see Fluke in Hioki. It requires more force, but it's not grippy at all. Look at this. This is not grippy, this is slippery as hell. It's like a banana peel. Why does Fluke make these out of banana peel? It's stupid decision. Absolutely stupid. The stress relief, yeah. The stress relief is not functional here. As you can see, the small radius, and the Hioki, not functional here either, small radius. Talking about the wires, the insulation on these is also different. Fluke has it more flexible, more like a little closer to the UL type silicone wires you can get from China for RC hobby. Hioki insulation is a little harder to bend, a little, somewhere between Fluke and my Unities, for example, made of PVC. Well, both are okay, and it depends on your preferences. I also have an example of 2 much flexible wires, and it is these are classic Chinese UL type silicone. Oh, don't mind this. I use these probes with my power supply to actually stick some voltage somewhere tight, and these needle tips, of course, gold plated. It's not Fluke, so it's gold plated. These needle tips are perfect for it. But this silicone wire, it tangles. It's like your headphones in your pocket. Yeah, these are pure silicone wires, and it keeps tangling, and your hands can't get out. That's the problem with too much soft insulation. There are people who would say, well, the softer the better. Hell no. If you live somewhere where there is minus 50 degrees Celsius outside and you would use your multimeter outside, then yeah, get these, definitely. But if you use in mild environment, if you have 20 degrees in the room, then don't use these silicone type wires. Now, let's tangle them somewhere else. So, these are, in my personal humble opinion, these are a little on the more softer side, not that sweet spot. These are on the sweet spot, or maybe a little on the harder side of the sweet spot. So I like this wire more, and also this is more slippery. As you can see, it's not reflecting, so it's smooth. It's smooth surface. like anti-glare display or something. But these are like polished, but they tend to stick. They just stick to itself. This is better insulation. Both are great, but this is better. Fluke also has this TL75 piece of shit. Well, this is TL75. This is TL175. This is just 75. It's 100 less, so these are different. These TL75s, the insulation is so hard that you could hammer a nail with it. You would be constantly fighting the hard insulation that wants to keep the original shape. It may actually be used as a personal defense weapon. You just use it as your knuckles. Here you have Fluke on you. Yeah, so these are even harder. The insulation is much harder than Slipknot brand. You hammer nails with them, not use them with your multimeter. TL175, that's the other extreme. No, not extreme, but that's completely different. So please, if someone says, "Oh, I have TL75," it's not this fancy TL175. It's this garbage. So please know the difference. Many people under my check video didn't know the difference between 75 and 175. I suppose they weren't paying attention in the school. Probes, bend relief. Fluke, again, useless. I don't like to do this bending, but yeah, Fluke is useless. But look at Hioki. This is how it's done, people. Great. At least someone on just one end, because this is shitty too. This is bad, this is really bad. But here, it's okay. I like it. Now, let's see them tips. To see them, we must make the mechanism uncover them. Fluke is covered with rotation. Not this way, this way. While rotating, the sleeve slides in, and in the window you can see the current cat rating. Hioki is different. You have this arrow and you follow the marked path. So we unlock, go up, slide back, go down, locked. Cat 2, 1000 volts. Fluke's solution is more fancy, definitely more fancy, but as there is some mechanism that translates the movement, it would be a little more susceptible to damage in case of ingress of some foreign particles in here. I suppose. Fluke's sleeve is also significantly thicker than the Hioki sleeve, limiting your abilities to stick it somewhere tight a little. Hioki has the sleeve more sleek and thinner. Fluke has this thread to screw on your banana adapter. Oh god, how I hate these bananas. When I was a kid, my second multimeter leads was these rotary bananas, and it was driving me crazy. I hate them. Since then, I was quite successful avoiding these. So, yes, here you have the option, and it's great that it can be actually unscrewed. Fluke has the tip more sharp. While Hioki has it more blunt. Sharp tip is good to penetrate oxidation layer on some bus bars and such. Hioki tips, on the other hand, are gold plated, which is how I like my tips. Gold isn't prone to oxidation as long as you don't scratch the gold plating off. These are gonna have perfect contact every time. I know the struggle having older nickel-plated tips and actually having to use my rubber to erase them to get the contact back and to get the oxidation out of it. It's an old trick, rubbering your PCBs and your probes and everything. And it works. Even my $100 unit rent, my $100 unit T has gold-plated tips. And boy, these are good quality. You can also buy gold-plated leads on AliExpress for a little above $5. These were $6 with the silicone wire, and these are $5 if you just buy them with PVC insulation. With older generation, but still relevant DT4282, you will get these leads by default. These more ordinary ones. Take the L9300, remove the covering gizmo and remove the bent relief, and you have the original classic leads. Of course, gold plated again. So these come with the DT4282, but I would recommend buying the 9300. Now the accuracy. We are gonna talk about the specs and also prove at least some of them whether they claim the truth. To get in the picture, most used better low and great multimeters usually have basic accuracy of 0.5% or 5000 ppm, while some of the more accuracy-oriented reach 0.05% or 500 ppm. Mid-end multimeters usually stick around 0.1 or 1000 ppm. Hioki here has basic DCV accuracy of 0.025% or 250 ppm, and Fluke is just 0.05% or 500 ppm. The Fluke multimeter that is considered to be high-end multimeter has the same accuracy as some of my little better low ends that cost around 70 bucks. Moreover, all these have higher number of display counts, but more on that later. Hioki is therefore twice as accurate compared to Fluke and has 3 times more counts. So that was the basic DCV accuracy. How about ACV, where true RMS converter is involved? Hioki should have 0.3% and Fluke 0.7%. My personal saying on voltmeter instruments is that below 0.5% we are measuring, below 1.5% we are estimating, and these 2.5% and more, like 5%, is just indication that something's there. That's all. You don't know how high, but you know it's there. This is the 5% and 2.5% instruments. So Hioki measures ACV and Fluke estimates ACV according to this. Let's join the resistance. Fluke has 0.2%, which is beautiful, one of the better ones, but Hioki Hioki slays with its 0.03% accuracy on all technical resistances. Oh man, Hioki's accuracy is just at the borderline of these classic 2-wire multimeters and lab 4-wire multimeters. This is the border. Hioki has also one more trick up its sleeve. Here we can see nanosiemens. In resistance mode, the multimeter measures with a very low voltage not to trigger any diodes and other silicon parts that would compromise the measurement. But for resistances as high as mega ohms and even higher, it's very difficult to measure with such a low voltage. So these nanosiemens, it doesn't restrict the voltage and lets the multimeter give what it can. Hundreds of mega ohms can be measured, no problems, in nanosiemens mode. Fluke seems not to have this function, which is just a supplementary, yeah, but it's nice to have it. To keep the accuracy current flowing, let's use the DCA. Hioki measures that from 0.2% up to 0.05%, which is really beautiful. Fluke only measures at 0.2%. The other accuracies I do not consider to be important, for example ACA. I have never in my life measured AC currents with a classic inline multimeter. Clamp meters, that's a different story. I use them at work, but never ever have I measured AC current with a classic multimeter. Capacities, well, multimeters have them, but it's unreliable function, as if you want to measure caps, you should use a proper LCR meter or at least a component tester. An electrolytic cap, like this one, it usually dies the way that it first gains enormous ESR and just after then it drops capacity. So you can't tell the capacitor life just by measuring capacity. You must measure ESR. Moreover, capacity is heavily dependent and influenced by working frequency. With LCR meter, you can set the frequency 100 Hz, 120 Hz, 1 kHz, 10 kHz, 100 kHz, or DCR, not for caps of course. But multimeters, they measure capacities with charging method, and there is automatic frequency that you don't know and you can't influence it. Now, the practical part. As I am no millionaire and this is stuff I do, is just my hobby, I do not possess any calibrators, so I had to improvise. I went to tme.eu, that's a great distributor for Europe, just like Mauser, Farnell or DigiKey, but TME is like 350 kilometers from here in Poland, so the delivery takes just a few days. Well, actually, I ordered these resistors from Mauser, and these were here in like 2 days via FedEx. and these are ultra precision resistors, but I don't have the PCB for them yet and the gold plated parts and everything, so we won't be using them, and we will be using the older so-called standard bunch of components instead. So the delivery from TME, it takes also just a few days. Well, if the Grzegorz Brzęczykiewicz guy in the warehouse, or however you pronounce it, packs and ships the parts swiftly. And I bought there the best parts available at TME. Well, available is the key thing, as there obviously were some more accurate parts with tighter tolerances, but I would have to order an entire pallet of these and wait half a year. So the best what was available there on TME, and in future reviews we will use the best that was on Mauser. The voltage reference is just a hair more accurate than the Hioki. It has 0.02% precision and Hioki has 0.025, so it's like 0.005% or 50 ppm difference. That's like, well, it's not like real test for Hioki, but rather to make sure neither of them is lying horribly. Testing less accurate multimeters on this is fine though. I then got these resistances. Beating Hioki's resistance accuracy is so hard though, so I calibrated these resistances with the Hioki, and we will be testing whether Fluke is a liar and Hioki will be the judge. Capacities, for them I bought a $400 LCR meter that you have just seen, so I could at least thoroughly test one of the Hioki's function, capacity measurement. Hioki has 1 to 2% and Fluke 1%. My LCR has 0.1%, so finally something to catch on. Oh god, how these accuracies are expensive. And it's just my hobby. This is my hobby. These are all borrowed. Oh man. I will just recreate the method and show you my table where I wrote all the data. The table has been filled after multimeters and reference have been running for a while and there was stable temp. This also depends on leads you use. I have always liked these bananas because you can easily stack them just one on the another, but this ring, the contact is so bad. So the measurements in the table were done with this. This is my high current XT60 to banana adapter. But for this test and for some higher currents I have already made these. So in my check video I have demonstrated on these. The table is measured with these. And now we will demonstrate on these, so it's like 3 sets of cables. For resistance measurement we must compensate the leads. With Hioki, I shall short the leads, then press rel, and then I am free to measure anything. The multimeter will auto-range accordingly and very fast. We are in megohms, boom, auto-range, we are here, beautiful. Unfortunately, I am not able to tell whether Hioki keeps within specs, but a quick check against my LCR says that these two come apart only in the last 5th digit, which is overall nice. This is how you measure resistance with your Hioki. Fluke. To get the best resolution, we must enable high-res mode, and if I didn't write it down I would forget about it. See how the backlight reacted to rising slope? Well, I will turn off the lights. So it reacts to the rising slope. So in this high-res mode I have switched from default 6,000 counts to 20,000 counts. Now let's connect the leads. Let's rel it. Rel. And now let's measure the COM1 140. The table is better for the values. What? You know what's happening here? Fluke doesn't auto-range in rel mode. I thought this is only present in cheap multimeters. And if I disable the rel, we still have no auto-ranging at all. Why did it stick to manual range? Oh, we are in low res mode. And now, range. I need to manually enable auto range. It used to be enabled. It used to be in auto range. I turned on rel, I turned off rel. Why doesn't it return? Now, if we desperately need the rel function, we can just stick the multimeter, let's say, somewhere in the middle. And then lock the actual range. Then short it, rel it, and we are free to measure. But again, we have locked range. So whenever I want to connect higher resistance, I need to first turn the rel off and then manually increase the range. Now, let's go on higher. That's 20, yeah. Higher. We must go upper range. So if you measure like too high, then you need, we are at 60 ohms range. We cannot while the rel is, yeah, 600. Hey, this is 200 kilo ohms. This is 600 kilo ohms. Why there is no, what? It's completely fine. It's completely fine. How so? Oh, here's why. The Fluke is a liar. It says the actual range is 6, but it can't be true because we are in high res mode. So it has 20,000 counts, not 6,000 counts. But somehow the multimeter indicates the range as if we were in low res mode. Oh man, this is bullshit. What the Fluke? I am actually most probably at 2 mega ohms range, but it indicates 3 times higher range. I'm out. This is unbelievable. It just causes confusion, which may potentially lead to major mistakes. Why the Fluke does it indicate currently selected range wrongly? If it can show both volts and also milli in front of V, why can't it show either 2 or 6 and then some bunch of zeros after it? Here, this is lame mistake, beginner mistake, low-end multimeter grade mistake. Screw it. Now I suppose the capacity is the same. So let's see. Now, nanofarads, okay. I can like, so they stick together. The capacity of the leads will be constant. Somehow, rel. Yeah, this is just. Yeah, we are at the range. Nothing. Yeah, it doesn't auto range. Let's see, Hioki. Let's rel them. Now, low capacity stuff, higher capacity stuff, 10 microfarads. We have auto ranging while the rel is enabled. And guess what? This is somehow even a standard. Look at this. You could have 2 of these multimeters for the price of 1 TL175 leads. Let's see how it works. Capacity, rel, lowest range, it's slow, but it auto ranges. This El Cheapo, this is cheap as hell, and it auto ranges in rel mode. Now about the range indication. So Fluke reports the range wrongly if you are in high-res mode, and if you are not in high-res mode, so you are inaccurate as hell, then it's okay. But in high-res mode, it lies. 60 millivolts, 600 millivolts, 6 volts, 60 volts, 600 volts, 1000 volts. Yeah, and in ohms, I can use just this range, 600 ohms, and it blinks here. 6 kilo ohms, and it blinks here. 60 kilo ohms, keeps blinking. 600 kilo ohms, keeps blinking. That's the actual range, and it's indicated. Great, just great, perfectly, I love it. And here, if we use the resistance, well, not only the range is... I was stamped there. What was it? Did you see? Nanosiemens? It has nanosiemens? Oh. Oh. Should it measure these? Should. So it's not nanosiemens. What is it then? I don't know. Really. One more thing. Low resistances. Hioki can go down to ones of milliohms, while Fluke down to tenths of milliohms. We have been looking at these for such a long time, and yet no words about them, so let's jump into the display chapter. As you may have heard, Fluke has basic 6000 counts, and in high-res mode, that we need to keep enabling all the time as the multimeter doesn't remember it, it has 20,000 counts. Basically, it starts using the one that's to the left. Hioki, on the other hand, has 60,000 counts by default, and even more, 100,000 counts for the secondary value. Oh, and also for memory you get 400 counts. More counts means better resolution, and it definitely comes handy if you are, for example, looking for small changes. Moreover, it helps maintain the accuracy as you have more digits put to use, and the plus minus, some digits in the accuracy specs, matter less. Fluke, on the other hand, has bar graph. Bar graph is great for looking at slowly changing values like from 0.1 up to 5 Hz. If your multimeter is on the slower side, then bar graph is often very comfortable to look at while, for example, incrementing a value on trimmer. And after you get it about right, you then focus on the numbers and fine-tune it to the last digit. To give you an example, this unit trend has just 3 readings per second, which is standard, but slow. Really slow. 3 updates per second is just not that comfortable to use. But we are lucky, as the bar graph here is implemented perfectly. The scale is clearly visible, and you can tell all the segments apart. No need to keep finding yourself where exactly am I right now. Just look and see. Both Hioki DT4282 and Fluke 87V Max have the bar graph not that well visible. It may be better visible if we use ohms, because it's full range. Fluke has 4 readings per second, that's the borderline, and all Hioki multimeters have, however, 5 readings per second. So these two have 5 readings per second, which is the maximum update rate you can process with your eye. When using the Hioki DT4261, I personally don't use the bar graph. I mean, I have never looked at it. 5 readings per second is fast. Sorry, the reflections I can't see on my phone. I'm recording on my phone, but I have a tripod in front of my face, and the only thing I see is the tube here. I sometimes when I focus on the display and I just see, all you see is these reflections. Sorry about that. 5 readings per second is fast enough for almost anything. And if I need to watch something faster, I use my scope. There must be, however, some applications where using a bar graph is just the right solution, as you can easily see, for example, capacitor charging. Where bar graph is mandatory is, for example, this amp probe. I have never ever met slower multimeter than this amp probe. It also eats 9-volt batteries by dozens. These amp probes being slow as Fluke, no, Fluke is faster, being slow as heck. The bar graph is mandatory there, but in this blue case, I could live without it. I don't even look at it in the DT4281. Maybe even in this yellow case, it would be okay without it, as it has 4 readings per second. But the bar graph is definitely nice to have sometimes when you don't have a scope. However, if someone plans to implement a bar graph in his multimeter, well then do it like this Unity. This Unity has perfect bar graph, clearly visible. I can't see shit in here. Which bar is what? I don't know. There is no gauge, nothing. Just like here. What is what? I don't know. Where am I? But here, I see it clearly. Oh, and these numbers are visible all the time. So they don't disappear, they are there always. So you know very well where are you going to. Great. Backlight, we have no winner here. Fluke has 2 levels of brightness. Come on. Yeah, this is better. It's on the bluish side. I don't like that. Well, actually, this is a little warmer white and this is a little colder white, but not as cold as you see it. Fluke has 2 levels of brightness, however, the highest is the only useful. But anyway, the color is neutral, slightly warmer white, something like 4500 kelvins, and I like that. Personally, I prefer lights around 4000 to 5000 kelvins, as they are most natural to your eyes, and also bring slightly better CRI, generally. Legacy Fluke 87V, without the max, actually has cold white backlight, and modern Hiokis have warm white backlight. As you can see, even warmer, then you can't see it. I will give you some photos. That's better, because the photos were taken on manual. All the Hiokis I have tried, like 4 of them, they all have very bright backlight. Unlike, for example, my Fluke 17B Plus or my Unitrend. But I almost never use the Unitrend's backlight, as it's power hungry even without it. So sometimes when data logging, I'm quite scared of the batteries dying. Never have they died during data logging though. Back to the topic, the viewing angles. From sides, they are okay. Just a bunch of reflections. From top, Fluke slightly disappears, but it's still great. And from the bottom, okay. So only from the top, Fluke slightly disappears, that's all. Let's talk about additional functionality. It may be unlogical to cover this chapter before DCV and ACV and DCA measurements, but there are actually some dependencies, so in order not to break them, this chapter comes sooner. Hold, that's often the only function some of the entry-level great multimeters have, but these multimeters have it more sophisticated. There is, of course, the classic hold. Just press to hold, press to unhold, that's that. Everyone knows that. Now, Fluke has something like auto peak hold, and Hioki has like a first touch hold. Fluke rearms automatically, so whenever any value stabilizes, Fluke automatically updates the held value. Hioki, once it triggers the hold, it needs to be rearmed manually by pressing the hold button. Let's demonstrate. First, the Hioki with the slightly more primitive hold. Auto hold mode. And now I get a lithium-ion battery. It's held. Now it won't update. Nothing. I need to rearm. Now the Fluke. I will use the Hioki leads here because they are gold plated and I don't want any errors. It automatically held. Now, new stabilized value. Now, another new stabilized value. Now, let's go back. Let's go to negative numbers. Beautiful. For me, the way Fluke does it is slightly more convenient, but you can also accidentally touch something on your way back and the value would update, losing your previously gained value. But that won't happen that often. Auto hold and classic hold are must-have functions for a clamp meter. Clamp meter without hold is useless, but these classic handheld multimeters, to be honest, I have never used the auto hold in them. And the classic hold only when values were changing fast and I wanted to freeze two multimeters at once, but no other use cases. Having such a precious, accurate and also expensive instrument, it would be a shame if we didn't use the measured data anywhere. Hioki can use its optical interface to connect to your PC. The only thing is you must buy the adapter, which ain't that cheap. For example, when I bought my unit rand, this one, the cable was already there in the package, no additional fees. So unless the software has some crazy functionality or unless your multimeter has some GPIB I/O, I think the COM package should be free, or at least for moderate price. More modern Hiokis also offer wireless connection, for example like this DT4281. While it's convenient for on-the-go type of jobs, when you are working by your desk, you want wired connection. Metallic media like this one, like this one, like this one, like this one, this one, this one, this one, this one, or this one. Metallic media is always superior to wireless. It's more reliable. Fortunately, every Hioki starting from DT4250 series up also has this infrared communication. They all have it the same. Fluke? No way. There is no connection here. Just grab a coffee or a beer, cause this will be long, and keep feeding your Excel manually with what you see. Numpad recommended. Memory. Some multimeters have memory for stored measured data. For example, my scope meters, they both have memory. Hioki offers total of 400 memory slots which we can access with this button, mem. .400 memory slots. Well, in my opinion, is just too much. You ain't gonna remember what's in the 396th or 287th slot. Hioki would better use the extensive memory for something like offline data logging. That would be really useful. I mean, you could just set your multimeter to data log, it fills up its memory, and then you just grab it, connect it to your computer, and download the data to Excel. Much better use for such a memory. Max and min statistic mode, they have it implemented once again differently. Hioki has it implemented the old and inferior way. I either go for max, sorry you can't see it, sorry about that, or min, and next press turns it off. Stupid implementation. I cannot list through them. I always lose the data. With Fluke in hand, you enable the min-max mode by first press. Now, then you are free to list through max, min, average, and the actual value. And list through them for as long as you need. And then turn it off with long min-max press. We are back. Fluke also implements average function as we have seen here. It's present only in the newest generation of Hiokis, for example DT4261, which also has average, but Hioki DT4282 doesn't have this. At least it has slow mode that can serve a slightly similar purpose. Unfortunately, enabling the slow mode doesn't add up any digits, as it usually happens with desktop multimeters. I would love to have 600,000 counts, but no, it's not possible in this form factor to have 600,000 counts, so 60,000 counts is still great. Both multimeters try to prevent us, dumb users, from blowing these HRC fuses, and they both do it different way. Fluke has probe sensing. In the banana sockets for amp holes, there are holes for sensing, so the multimeter knows if you have inserted anything into the current holes. Let's insert to the amp hole. I cannot hear anything, but it says lead. Now, the milliamp. I once again can't hear anything, but it says lead. Hioki has done this protection mechanically. Whatever function you have selected, only the sockets that you should use are available, and all the others are mechanically covered with a shutter. It also prevents you from switching to somewhere else while having your red probe in wrong socket. We may see this solution, for example, in Gaussian metrawatt or Holt peak. You can't physically switch to another current unless you take out the probe. Now, milliamp, microamp, I am free to switch through them, but I can't go to capacitors and to amps, so I need to do this, and now I am free to use anything I want. Beautiful. Let's see some other multimeters that also have probe sensing. As you can see, there is no amp button, and well, I quite like these button controls. These, like go to right, go to left, I don't like them. They are too slow to control. But here you just press whatever you want to measure, and you get it instantly. So now let's insert it in the amp. Boom, we are in DC milliamps. It will range up to amps eventually. Yeah, now microamps. Boom, microamps. Beautiful. Now here, amps. We are in amps. Great. So this is probe sensing. Now, the shutters. Hioki is not the only one who has it. Gaussian metrawatt, for example. I believe Kyoritsu has it too. And this Hot Peak. Chapter mechanical. Hioki has a little sharper irritation. Fluke is more plasticky, but both are great. Now, imagine you have a Fluke laying on your desk and you want to measure something. You must be thinking, what the hell is he gonna do? But look, I turn the multimeter on, and then you insert your probes in your multimeter, and boom, you can't see what you are measuring. What the hell, Fluke? Again, so first come the volt, and now nothing, I can't see anything, so I may be probing whatever the hell I want, but I won't see it. Why? Because the multimeter is as unstable as Windows 95. Look at this, what the hell is this? Why does your multimeter roll 15 centimeters away? I want my multimeter to be here, not here. What a stupid idea to make multimeter that would also supply for a road roller. You can roll hot asphalt with this multimeter by just rolling it all the way. If it can't lie, can it at least stand? The stand or leg or bale or whatever you wish to call it, it has insufficient rubbering down here. The rubber doesn't cause enough friction, it's just slippery. Moreover, it's distributed more to the center than to the sides, which in cooperation with quite rounded bottom of the multimeter will have your instrument constantly swinging and falling and tilting and everything. It's just as unstable as if you would fill up your pressure cooker with a plutonium. Let's see Hioki. The corners, these are sharp, and these are sharp too. They enhance the stability. The stand, not only is it rubberized mainly on the sides, but also carries power-on shortcuts. So I don't have to stick my nose into manual whenever I want the multimeter to boot up in a special mode or adjust something. Perfect. The stability of Hioki and Fluke is really uncomparable. Stop swinging! The stability of Hioki and Fluke is really uncomparable. And guess what? Even my Fluke 17B Plus is unstable as hell. As you can see, ow, my finger. Look at this. It can't stand. Piece of garbage. Ow, my leg. No. You go somewhere else. If the Flukes would actually hold on your desk and not use every occasion to fall off your desk, that would be really nice. And maybe the Fluke would even not have to be so tough, because if it wouldn't be falling so often, it wouldn't experience such a high number of impacts. Why do the Flukes tend to fall on the floor? Why do they make their multimeter so stupid unstable? This is ridiculous. Beginner mistakes were made. Why is this industrial standard as unstable as if you would put a plutonium in your pressure cooker? Why the hell? Why are they rounded? Why? Why is it so stupid? Why isn't it like this Hioki? These corners, perfect. It holds. Moreover, inserting leads, look at this. I can apply any pressure I want. My finger is red. And nothing. And look at Fluke. If I want to insert a banana, boom, it's somewhere else. I need to get it back. Now insert the second banana, boom, it's somewhere else. And I need to roll it back. Why the hell Fluke? Why can't it lie? Why can't it stand? Why does it fall? Absolutely stupid design. Anyway, AP67 here. The multimeter can even be a little submerged under the water. We aren't going to test that though, because it's not mine. Hioki DT4282 ain't waterproof. Fluke also brags about its working temps. Long term, that means the multimeter can actually have the temp even inside, and it will be working permanently in the temp. The operational range is -15 to +55 degrees centigrade, of course. And DT4282, being more the lab multimeter than your technician's multimeter, has exactly the same temp range. DT4282 is more for desktop work than for field jobs. It's not expected that you will have -15 or +55 degrees in your office, but still, nice numbers. Since both multimeters have the same minimal temp, I set my freezer from -18 to -15 and placed both multimeters in there for a few hours. Please don't mind the circuit breaker, as it's part of my test of 4 different label tapes for Brother P-Touch standard. When I took the multimeters out, I had hard time reading the displays because the plexiglass is kept fogging. Both multimeters worked perfectly, however. Of course, their measurements were a little off, but still within specs. Let's return to the -15 to +55 long-term operating temps. There is this Hioki DT4261, and it goes 10 degrees further for both temps. So from -25 when half of the cars won't start, up to +65 when you would die. And it's not even marked as rugged multimeter. It's not as rugged as Fluke, and it still can operate in 20 degrees wider temperature range, long term. All Hiokis are drop proof up to 1 meter, as they say. Fluke 87V Max being the sturdiest variant of 87 series, it should be 4 meters drop proof. I, however, wouldn't trust the stand, and if you would have your leads still inserted, I wouldn't drop it, because this would represent a problem. Inserted leads and stand. We will, however, see the rubber, how it's done, and I must say I would happily drop the multimeter if it was mine. If I was sure that it would land on the bottom or on the top. Fortunately, all the Hiokis and also this Fluke 87V Max, they protect their display plexiglass and also slightly the selector, and that is done by overhangs. We can see this beautiful overhang. Fluke has this beautiful like cap overhang, and in my opinion all mobile phone cases should also have such an overhang. For example, Hioki DT4261 has overhangs on the sides. Slightly different solution, but it works as well. It will land on the rubber, not on the selector. Beauty. Here it lands on the rubber. DT4282, however, is more the laboratory type, so it only protects the display. The selector would therefore serve as an additional bumper, so you would have it scratched if the multimeter would fall too often, which won't happen because it doesn't swing, it just holds on your table or on your desk. Continuity tester or buzzer or beeper or whatever you call it is one of the two absolutely basic and fundamental functions of any multimeter. Globally, the most used functions is voltage measurement and continuity test. So any multimeter must handle them well, and high-end multimeters must be excellent. Meanwhile, with any Hioki multimeter you buy, you get gold-plated probes. Flukes, however, have no such option. Nickel, or whatever it is, it's nowhere near perfect. And let me demonstrate some of my nickel-plated leads. These are ordinary nickel-plated. Brand new. So, we must use something better, like these Hioki gold-plated probes. Let's have a look. Perfect. I don't know why Pomona can't make them probes right. And therefore I will allow Fluke to cheat, so both multimeters are tested under the same conditions. Fluke will also be using gold-plated leads from Hioki, although you may never get some with any Flukes. So let's try beeping with Hioki. Just get the selector there, and that's all. I can instantly begin testing my continuities. Here we can set the threshold. This is the threshold, which is great for filtering out some of like relay coils or resistors and such things. And look at the reactions. Absolutely perfect. So what we get here, nice, loud and clear beeping. Secondary indication. Instant reactions. Perfect. Just perfect. The loudness of the beeper, I have measured it 20 centimeters from the multimeter stop in silent conditions, which means there was no humming of water pump in my PC or running television in the next room or blowing fan to the left and such. Hioki produced sound level of 69.5 dBAs, while Fluke, do you know how the Fluke was loud? Just 56.5. 17 decibels difference. You know what that means? Every 3 decibels down is half the music power. Mega ohms, nanofarads, mega ohms, nanofarads. Oh yeah. No, this is the beeper symbol. I can hear some. Yeah. Can you hear it? So we aren't beeping. You know why? Because you must go back to the mega ohms and then go to the beeper. Stupid. Let's try the beeper. Can you hear anything? I must not be talking loud, otherwise you won't be able to hear it. Can you hear something here? I can barely notice something. What it is? Where does it come from? I don't know. Some silent buzz. Yeah, it comes from here. It's the same background noise. I can't recognize anything. So the difference, 17 decibels. 56.5 dBAs at 20 centimeters. The multimeter has a hard time over beeping just your voice or any background noise. Just one fan and you won't hear the beeper. Imagine taking this so-called industry standard near a running machine. You wouldn't hear shit and wouldn't even be able to see anything because there is no secondary indication. You would just have to wait until there is some value displayed on the display. Or working in an office, every coworker would have to shut up and stop drinking his coffee, and just after then you could hear your Fluke beeping. Of course, any chirping birds outside your windows would break it and you wouldn't hear anything. One could say that the silent buzzer is caused by the IP rating. Well, good guess, but not exactly. Look at this Fluke 17B+. It's so silent as well as the Fluke 87V Max. It's the same, not loudness, but silentness. Let's try and probe. The multimeter is so damn slow that it takes weeks for it to auto-range on the respective range, and then you wait months until the value is integrated. A little bit louder, but not like Hioki. M-probe is owned by Fluke, so, well, why aren't you using better buzzer? At least the less silent one from M-probe. Why make your buzzer that you can't hear? It's not the IP67 rating problem, it's the yellow problem. Look at this. This is a few bucks from AliExpress, and how loud it can beep. Loud and clear, and secondary indication just as it should be. When this El Cheapo is so loud and also has secondary indication, and this Hioki that is quite expensive but still great multimeter, when these can have it, why not these? Well, this one is obsolete, so well, it goes out, but these are not obsolete. These are current multimeters. These are made today. Fortunately, I have a solution for all the Fluke owners. Behold, the ultimate buzzer box. I will decrease the volume in editing software so you can hear the beep without bleeding from your ears. These buzzers are made in black and yellow, I believe, and the yellow, oh, what a coincidence! The same yellow as Fluke. So these two come together. You may glue it somewhere, for example here, or to the back. Yeah, that's better. And boom, you have all-in-one instrument. So, for some reason, if you decide to buy Fluke 87V Max or Fluke 17B+, an incomplete functionality multimeter, and you really want to continuity check because it's one of the two fundamental functions, you must carry an additional box, glue it here, and then use separate leads for beeping and separate leads for measuring. Fortunately, Hioki needs no such a gizmo, as it already implements both loud buzzer and visual indication. Let's go to diodes. Fluke has open voltage of 2.4 volts. That's for maximum some green or yellow LEDs, nothing more. Have you noticed how one of the most used functions, buzzer, is stuffed here in already populated selector position with two other functions, while stupid diodes that get used rarely get a separate selector position just for themselves? Ain't this stupid? Anyway, Hioki has astounding 4.4 volts. So we could easily probe around LED panels, broken LED PCB strips, and easily fix them with Hioki's diode test. No problems. Oh, both multimeters beep below a voltage threshold to indicate burn-through diode. In the yellow case, only God knows the threshold, but in blue case, you can set it. Once more, just like for continuity. Another great idea. Well, Fluke has one more trick up its sleeve. Let's try an actual diode. So this is classic diode. So, what? Could you hear it? What? Yeah, so you can hear it? Ooh, yeah. You are. Just now, can you hear it? Almost nothing. What is this? This is supposed to be something? I don't know, man. Well, let's try Schottky diodes. This is Schottky diode. What? Did you say something? Huh? Probably nothing. Let's try this bridge. Minus, plus on minus, minus on plus. This time, nothing. Let's try white LED. It glows, but just a tiny little, you can't recognize it. Let's try Hioki. So, if it's shorted, it will beep. If it's not shorted, it's not. So 0.15 volts is the threshold for Schottky diodes. Oh, it's so low voltage that it beeps. It thinks it's burned through. So yeah, it reports burned through diode. Anyway, let's try something. Well, this is 40 amp diode, so and low voltage. So the dropout is very low. Let's try classic diode. It won't beep. No, we can go higher. As you can see, it's okay. If we set it for 1 volt, it would beep because it's below the voltage threshold. Let's try this diode bridge. Minus goes on plus, plus goes on minus. It's slightly below the 1 volt, and it's okay. And let's try the white LED. Beautiful. 2.4 volts. The current is small though, but it definitely helps. Yeah. So these two implementations are a little different, as this one has adjustable threshold and this one relies on the beeping. Let's try if it actually beeps if I short it, because I haven't tested that. The delay, oh man. Such a delay, come on. Let's try the newer Hioki. It may not have the adjustable threshold, but it has one more trick up its sleeve. The open circuit voltage is low here though, so it's even worse than Fluke. It may be constantly beeping because the dropout here is so low. Yeah, it's beeping. Let's try the classic diode. Aha! So beep, 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 beep means classic diode. This is the indication of present diode. Not the short beep like in Fluke's case. The short beep that you couldn't even hear. Resistance. Both multimeters of course measure it, but only Hioki works good in rel mode, and only Hioki has the nanosiemens mode indicated here. It's dedicated nanosiemens mode, as we have already seen. If you want to use nanosiemens with Fluke, you may well forget that you have nanosiemens ability in this multimeter because it's nowhere to be seen. If you want to get to nanosiemens mode, you must, well, yeah, nanosiemens mode. This is inconvenient, and you don't even know, well, at first, in my check review, I thought the nanosiemens mode is not present in here because it's nowhere to be seen. But after then I just was playing, after the review check, I was playing with the wrench on the ohms because, well, it drives me crazy. And then I found it actually has nanosiemens mode, but it's nowhere to be seen. Meanwhile here, you can, and we are in dedicated nanosiemens mode. Now, capacitors. I repeat, this is just a supplementary function, as any $12 component tester will do it better. And of course, then there are LCRs. I usually measure the time it takes to measure 25 volt 1000 microfarad capacitor. You usually find them in 12 volt power supplies. Let's try the Hioki. Before you measure any capacitor anywhere, in your component tester, in your LCR meter, in your multimeter, short the leads. If you know it's charged, then discharge it to a resistor or a light bulb. And if you don't know whether it's charged, just short it. And now it's safe. Because you may as well break the capacity range on the multimeter. Let's test for the speed. 3, 2, 1, now. Hioki takes about 7 seconds, which is the global average across all the multimeters. However, Fluke takes just 3 to 4 seconds. Yeah. Let's short it. And now 3, 2, 1, take. Yeah, 3 to 4 seconds. And this is quite very fast for a multimeter. So, well done, Fluke. At least something is implemented well here. Not that fast. I just remember there is the rel problem and the problem with being stuck in the manual range. So I take it back. Both multimeters measure temperature with any standard K probe. Both write open, yeah, same letters. Open in degrees Celsius. How much is open? They both will take just any standard K probe. You may use the drop one, this is the droplet one, or you may use the stick, the long stick with handle. Well, 26.7, oh, that's not true. Let's see here. That's better, but still. It's 23 here. DCV is alongside with the continuity test the globally most used fundamental function in multimeters. As you can see, I just pushed any multimeters I could fit into the image, so you will see just everything. Hioki used to have the fastest DMM chip in its ages, but who knows whether that's still true. I mean, it has been 10 years. Let's test some more multimeters, some more instruments. I forgot. I have wrote it down. To enable the high-res, I would forget it. One more thing before we begin. Generally speaking, the more accurate your multimeter is, the slower it is. DT4282 is 2 times more accurate than Fluke, and Fluke is 2 times more accurate than DT4261, and M-probe is the least accurate. So, if they were done equally, then a DT4282 should be the slowest, and M-probe should be the fastest. Let's see. You can adjust the playback speed of the video if you want. Let's try generic Eneloop Pro. Generic AA battery. 1.2 maybe. Let's see. It will probably overshoot. Yeah, slightly. 3, 2, 1, now. Again, 3, 2, 1, now. Again, 3, 2, 1, now. As we could see, fastest, second fastest, third fastest, slowest. Let's see lithium ion. 3, 2, 1, now. I'm not used to switching ranges, sorry. 3, 2, 1, now. Again, 3, 2, 1, now. Again, 3, 2, 1, now. Now let's try 9-volt battery. Switch range, OK range, OK range. 9-volt battery. Oh, I hate these because of M-probe. 3, oh, you wouldn't see the Hioki. 3, 2, 1, now. Again, 3, 2, 1, now. 3, 2, 1, now. 3, 2, 1, now. And let's try the Parkside X20 volt battery. It's just 5 lithium ion accumulators in series. Just your classic 18/20 volt battery. 3, 2, 1, now. 3, 2, 1, now. Again, 3, 2, 1, now. And once more, 3, 2, 1, now. M-probe is the slowest, that's for sure. It's a snail. And DT4261 seems to be the fastest. Yeah! And out of DT4282 versus Fluke, from this comparison, DT4282 is faster than Fluke. Not only it's twice as accurate, but it's even faster. When thinking about this, Hiokis are the fastest and Fluke-owned multimeters are the slowest. Actually, Flukes aren't that slow, and they are just average. It's the Hiokis who is really fast here, and I must say, from using these multimeters in practice, it's so comfortable to work with really fast multimeters, and also loud enough so they overbeep even distant hydraulic pump we used to bend bus bars. Well, you quickly get used to them. There is no coming back from Hioki. Millivolts. We usually don't use them, but some of us may be probing around operational amplifiers and current shunts. Just these things where even few millivolts may take a huge difference. So Hioki is therefore better suitable for measuring and probing around current shunts, around operational amplifiers and such things. Let's see how they react to dangerous voltage above 1 kilovolt. Hioki announces presence of high voltage with loud beeping, blinking red backlight and blinking over 1000.0 volts. Yeah, everyone around is gonna notice that and turn the source off. Fluke measures further, which it can, okay, whatever, but our high voltage indication is just this tiny bolt. No one will notice. Let's try the maximum measurable voltage until it triggers overload. For this, I have this utterly safest device. Look at these contacts waiting for me to touch them. And this box is for breakdown voltage testing. Let's try it out. 1040, 1050, 60, 70. It's 1080, I believe. 1080. Oh, 1085. So yeah, just OL, no warning beep, no blinking, nothing. How do you notice you are gonna die? Most of the multimeters usually do some sort of warning beep alongside with the overload indication, but Fluke does nothing, just OL. Will you notice this? This is your warning that you may die touching these leads. This is your warning. It's just nothing. Once again, for comparison, the Hioki. Much better. Much better. I usually don't care that much about ACV when reviewing multimeters, but here it's something different, that both multimeters have a peak mode, and Hioki, moreover, has smarter RMS converter. First thing first, bandwidth. Cutoff frequency is the frequency where reading drops by 3 decibels. I have tested this on my El Cheapo 100 meg function, and Fluke seemed to drop by 3 dBs at 213.8 kHz. That would mean the multimeter should be somehow accurate up to, let's say, 80 to 100 kHz. So even some of the lower frequency power supplies and older DC to DC converters, Hioki, on the other hand, has cutoff frequency of 920 kHz. So it's effectively useful up to, let's say, 400 kHz, maybe 500 maximum. Hioki would cover all classic power supplies and most of the switching DC to DC converters. Usually halving the bandwidth gives you maximum operational frequency, and dividing the bandwidth by 3 should give you accurate reading. As Hioki has quite high cutoff frequency, it also comes handy that it implements dBV and dBm measurement. For dBm calculation, we can set the impedance on startup. Both multimeters also have filter option. It applies low-pass filter of approximately 630 Hz to filter out some of the switching frequencies and some other stuff. For example, when you make a sine wave with your PWM signal. One thing I found is that Hioki, when the filter is on, it rejects smaller amplitudes. I don't know why. Both multimeters have peak mode, and both can serve two purposes. First is that they can look up for short pulses or short peaks and measure them, catch them and show them, like an inrush current, for example. Second is that they can easily measure ripple as volt peak to peak, just like you measure with your scope. For example, 100 Hz ripple on your input capacitor. Let's demonstrate. We have a signal. Let's say this was a charging and discharging capacitor. It's actually sine wave, offsetted. The sine wave has amplitude of 10 volts and offsetted up by 5 volts. So the bottom peak is located at 0 volts and the top peak is somewhere around 10 volts. With classic multimeters, you only have DCV and ACV. In DCV mode, the multimeters apply low-pass filter and they only measure the DC part of the signal. In this case, it's the offset of 5 volts. In ACV mode, Multimeters do the exact opposite. They see the signal as if it had no offset, just sine. But the multimeters will only show us RMS value. So knowing what the waveform looks like, yeah, we could calculate our volt peak to peak back from knowing the RMS value and both a DC component. But well, if we don't know what the waveform looks like, if we don't have this instrument, then we are doomed. And that's when peak mode comes to the rescue, as it effectively traces all the absolute minimum and the absolute maximums the signal reaches. This way we can tell the whole range. Unfortunately, if there would be a noise, we have pretty high chances to catch the noise. So the signal shouldn't be dirty, or we should use additional filtering. Let's enable peak mode here. It doesn't go from -5 to +5. You know why? Because we are in the ACV mode. If we switch to either DCV mode or combined mode, the reading is fine. Now, with Fluke, we go to min-max and then we switch to peak min-max. Now, the maximum peak, the maximum the signal gets to is 10 volts, and the minimum where the signal gets is 0.0 something volts, like here. Now one additional function only Hioki DT4282, DT4261 and CM4141-50 and other more sophisticated Hiokis have, and it's combined AC-DC mode. In this mode, the RMS converter integrates the signal as it is. No low or no high pass filtering is applied. So if you would pass such a signal into resistive load, this is the exact power potential. As you can see here, RMS value from the scope, I can measure dVm. So the RMS value is approximately 6 point something volts RMS according to our scope, and so says the Hioki. Unfortunately, Fluke doesn't have this function, and moreover, as it has just single value display and not dual display, we must be listing through the min-max all the time. Moreover, this combined AC and DC mode can be used to tell whether there is some live wiring or whether it's safe to work, but that's not the subject of this video. When it comes to currents, multimeters must handle very wide range of them. Here I would make a message to Hioki. Guys, please honor the name of multimeter, mainly the multi in it. It's 2023 and every serious multimeter has both low and high currents. Your Hioki DT4261 would be such a beast, and it would beat just any multimeter around its price, but it actually doesn't. Many people have written to me that the multimeter has great functionality and they would love to use such a machine that was shown in my review on my primary check channel, but they didn't buy it. Just and only because it lacks low currents. And as the DT4282 was too expensive for them, so they mostly went to Unity, because every Unity multimeter for reasonable prices, they have both currents. They are fully equipped. It's a pity. You are doing great job, guys, but then you kill it with lack of one of the common multimeter fundamentals. These people, they were looking for serious multimeter for their projects or even work, and they were planning on spending up to approximately $200 mostly, and when they saw my review on how great job you guys do with these machines, these people would be willing to spend even 50% more, because it would be worth it. But it isn't. What's the point of having mid-end multimeter with all the fancy stuff and everything polished to the detail when it lacks one basic function? Would you carry two multimeters with you because of this? No, you would carry one multimeter that can do everything you need. That's the spirit of multimeters. Please, you are doing great. Just abandon this one current range and make your next multimeter fully equipped, just like DT4282. The lack of milli and microamps is the only thing that breaks your sales. One would say that the DT4261, yes, it can go down to 0.1 milliamp, but in reality you cannot trust even the ones of milliamps in this multimeter, because it's going far beyond its abilities with such a low resistance shunt. That's the only thing that kills these mid-ranges, the absent milliamp and microamp range. If it had both currents, then this would be maybe your bestseller. Seriously. Let's return to the topic. Both DT4282 and 87V Max are fortunately both fully equipped with currents, so we can measure from the input to your room heater down to input current of your microcontroller in sleep state. Hioki can go down to tens of nanoamps, while Fluke can only go to hundreds of nanoamps. The resistance of Hioki's milliamp shunt is 2.5 ohms, while the Fluke has slightly better 2 ohms. This will result in a slightly lower voltage drop, but also reduced accuracy. The main shunt is the amp shunt. Well, this is tricky. I wasn't actually measuring or reading values of the current shunts inside. I was passing nominal current through the multimeter respective range, and while having the multimeter opened, I measured the voltage across the plugs. So we know the actual resistance socket to socket, and some flimsy banana cables cannot influence our precious measurement. So the value of 36 yellow milliohms or 30 blue milliohms is the resistance you would measure between amp and COM sockets. It's the resistance you as user are interested in, because the higher the resistance, the more the multimeter will heat up. These values are actually pretty fine, because there are HRC fuses that surprise also contribute to the overall socket to socket resistance, and they can dissipate significantly higher heat power. But still, Hioki will dissipate slightly less, and also the device under test will be slightly less influenced by the voltage drop or burden voltage. Both multimeters can measure frequency, and both are perfectly stable after 1 minute of 90% load. How do they react when we overload them? Hioki blinking, beeping. Perfect. I know that I have overloaded this multimeter. Fluke. We are in AC. Why the hell does it default to AC? Oh my god. So Fluke, just blinking, not beeping. So you never know when you will blow your fuse. So in case you would be so unfortunate to burn your fuse, let's see. If I would burn Hioki's fuse, I would have to grab PH2 screwdriver and undo these two bolts that are captive. Come on. These are captive, so anti-losing, as you can see, and I have full access to my fuses. It's very easy, although it could be even easier, just like the newer DT4261 has it. But yeah, it's good, it's easy, like half a minute or a minute. Now, let's see if I burn fuse in the Fluke, what do I need to do? I need to strip it out of the yellow rubber case. The tilting bale has already fallen out. Wait, is this? Oh, nasty. Can you see it? This is the legendary quality of Fluke, $800. Wait, does this Fluke have the same quality problem? No. Yeah, come on. No, it's perfectly fine. So, why is this case of Fluke 87V Max so crude? Anyway, it's nice chunk of rubber, definitely would withstand some fall. Yeah, the energy of the impact would definitely be wasted in this chunk. Now, what do I need to do? Oh, so many screws. Actually, bolts. These are bolts, these are screws. So it's Torx. It's Torx 10? Yeah, T10. So let's undo these bolts. Yeah. These are loosey. You can lose them. Wait. Magnet. Yeah. And these are anti-losing. This. Oh. Screw it. So they are undone. Oh, look at this. The batteries have fallen out. How do I place them back? Yeah. Oh. The middle one. Screw this. Oh, my bolts. Who the hell invented this? Let's take out the bolts and put them to the magnet all together. 1, 2, 3, 6, yeah. At least these are brass inserts, just like Hioki has. So, where are the fuses? I don't see them. They are under this rubber cover. Oh, no, they aren't here. So how the hell do I access them? Something has fallen out. Yeah. Here they are! The milliamp one is shorter. Shouldn't they be like 38 millimeters? These PV10s, they are 10.3 by 38. Oh, the foil, I should tear that off. So it's like 33, and this is 38, just as it should be. But this one is shorter. Why? Why is it shorter? Anyway, so these fuses are accessible after you undo 6 bolts, then you lose them, and also you lose 2 of your batteries, and then you can lose the rubber part and the plastic part, and after then you can change your fuses. Battery and power management is where they heavily differ. Fluke runs off 3 AA's, and I like that. AA's are great for this. You can even turn on your backlight, unlike in these power-hungry multimeters like M-Probe that eat the milliamp hours by dozen, and may God have mercy on your soul if you decide to use the backlight here. Back to Fluke, that on DCV consumes just 1.6 to 2 milliamps. That is unbelievably low, for real. Fluke must have definitely cared about the battery consumption when designing the microcontroller. This multimeter would last 53 days constantly running, which I consider to be awesome. Such a long battery life. Oh man. When the batteries drop to 1.13 volts per cell, the low battery indication appears, and if batteries are at 0.93 volts, the multimeter shuts down. So it can be powered by nickel metal hydrides, no problems. Moreover, these NiMH batteries, they won't leak, and if you buy genuine Eneloop ones, they can last many years before they need to be recharged. Hioki DT4282 runs off 4 AA's, so again, good battery type. Although to see classic 18650 in a multimeter would be surely even better. There are 3 multimeters out there that already run on these standard lithium-ion cells, and man, these are great cells. So Hioki, if you watch this, please consider 18650 or even better 21700 as your next gen battery type. They are great and they are everywhere. As today, in 2023, you can get them lithium ions, 18650s and 21700s everywhere. They are everywhere. You can buy them just at any shop. So maybe it's time for multimeters to switch to another better battery type. And it's standard. Unlike, for example, my Unity LCR meter that has non-standard battery type. and there is no excuse for that. DT4282 eats approximately 16 to 17 milliamps, and that is much higher. Yes, it has twice the accuracy, and the voltage reference inside must also be more power hungry. It has a dual display, faster acquisition, faster readings per second, and PC communication, but I still think that the consumption could be a little lower. Hioki would last 6 days straight. Not great, not the worst. Hioki can also be powered by rechargeable nickel metal hydride batteries, which I heavily recommend. Fortunately, the access to batteries is much easier here than in the Fluke's case. When it comes to battery power, Hioki has 3 tricks up its insulation sleeves. First trick is the battery indicator, as we can see here. You just instantly know if the multimeter would last another, for example, 2 days, or whether you need to recharge the batteries before you jump in your car and go somewhere measuring for 2 days. I have only seen battery indicators in graphical multimeters. In fact, some people told me their Keysight also has this, and you can even select the battery type you have, so the indication would be more accurate. And that's even better. So Hioki, please, implement some setting for battery type in future. Well, if you wouldn't use these standard 18650s, which are definitely better and far superior to the old and today quite even obsolete AA cells. Second Hioki's trick is battery warning latch that Fluke doesn't have. Fluke is not latched and Hioki is latched. Let me explain. Let's say you have some weak batteries, either discharged or it's freezing winter or just some shitty zinc carbon batteries. It's just the case that your batteries would have high internal resistance and tend to drop voltage under load. So either freezing winter, discharged, or bad batteries. It's very common for some 9-volt block-powered multimeters, even under normal conditions, that, for example, when they beep, the battery doesn't withstand the current draw. Metex even used to reboot. Anyway, your backlight consumes like 30 milliamps and buzzer may consume similar current. If your batteries have high internal resistance, like the cases we mentioned, they act like charged, so no low battery indication is present. But if you use the continuity check and you turn on the backlight, you may not notice that during beeping that the battery low indication may come on, because it disappears just right when the beeping stops. This is how just any multimeters have it, just like Fluke. But Hioki remembers if the battery has been low, and the indication in this case, its blinking battery symbol, empty battery would be, and blinking, which is easier to notice because it's blinking, then this symbol will be constantly blinking no matter what. So even after you stop beeping, even after you turn off your backlight, you will still have the battery symbol blinking. So you will know the battery has already been at the minimum. This is smart, really smart. And Hioki is the only multimeter where I have seen this function. Latching battery indicator. So to simplify this, Hioki basically shows the lowest battery level since startup, and it doesn't increase based off the actual battery voltage. Third trick is APS indication. Usually multimeters have 3 power states. First is power on, second is standby or sleep, and then is deep sleep. If you wouldn't touch any controls of your multimeter for 15 minutes, Hioki begins blinking the APS icon and then enters sleep mode. Unfortunately, it doesn't have any warning beep, and I think it should have it. In sleep mode, the multimeter has turned off almost all the internal circuitry, but the display would show APS and the multimeter is waiting. Should you press any button or move the selector, multimeter wakes up. If not, after 45 minutes, the multimeter turns off entirely and the selector must go back to off position and back to turn it on again. This behavior is quite normal. Many multimeters have these 3-stage power, and many of them can be awakened by buttons, but most of the multimeters won't show anything on the display. Hioki is the only one who shows APS on the display, so you know that it's in the sleep state and that it can be waken up by any button or any movement. And one more quirk. If you have this M probe or any other multimeter that has this bug, stop using M probes when the battery low indication comes on. These M probes, they have no cutoff. So it will continue measuring until the voltage of the 9-volt battery would be so low that some components of the multimeter wouldn't have enough power to function properly, and it will measure bullshit. Be careful around these amp probes. Instead of turning off, they rather give you false readings. It's a trap. Whenever you buy a new multimeter, test your voltages for when low battery indication comes on, and test whether your multimeter turns off. Fluke has better contacts. They are as springs from both ends. The positive is springy and the negative is springy too. So if your multimeter would fall, then upon the impact the batteries would have momentum, and these springy contacts from both sides really help to absorb the shock. While this standard solution, it doesn't absorb the shock that well. Let's undo all the screws. Oh, these have a rubber O-ring, so beware not to lose them. Let's open these multimeters. First, the Hioki. Oh, it won't come off because there are some screws even here. Yeah, so you need to remove the batteries. Yeah, they are smarter than me. Yeah. Is it the same as these? Can I put them together? It's the same. Okay. At least these are the same. Oh, I cannot open it because I have fuses. Let's use flathead screwdriver and gently remove the fuse. Oh, fast acting 630 milliamps, 1000 volts. What is written here? Holy moly, 630 milliamps. Beautiful. Now this, I'm bending the plastic. It goes like this. Oh, what a sound! Can you hear it? 11 amps. And now I can remove the back. Oh, look at this. Yeah. Oh, gold-plated contacts. Beautiful. Now let's remove the back of the Fluke. Standard, probably nickel plating. The input protection, it consists of the PTCs here, then there is wire wound, most probably fusible resistor, and the high voltage protection, here we can see GDT, gas discharge tube. These are made in different shapes, and here are varistors. We can remove the shielding, and believe me, the black plastic is really shielding. Let's see whether they are conductive. Fluke. There is something. Yeah, look at this. These are definitely conductive, but I can't find the sweet spot. And this, yeah, conductive too. It's playing games. So these are slightly conductive, and these act as a shielding. Older multimeters, they used to have like aluminum foil, but this solution may be better. Both are attached to the board with just one bolt. And let's lift up the shielding. Ooh. Oh, look at this. Now the Fluke. It's not here. It's here. But it's PH1. PH1. Yeah. So, Hioki, Hioki, at least on this side, is definitely more populated. I won't be going into details. Here I can see a switching power supply, some caps, diode, coil. It should be switching power supply. I won't be touching any of this area that used to be shielded because, well, it's not protected. So here we have varistors. Hioki doesn't have varistors, but this GDT. Here we have these contacts, PH2 bolt, There are washers here. There is no washer here. These are just washerless. But whatever. If it holds, it holds. This is a protection for the current shunt, and here I cannot see the current shunt, so it may be from the second side, because these are connections. It should be somewhere around here, the current shunt. But the current shunt here is from this side, and it's 4-wire current shunt. Beautiful. What is this? Can you... Oh my goodness. What the hell is this? Is this supposed to be welding? Like spot welding? Oh my god. I will give you some pictures from my microscope because my phone is not powerful enough for such a photo. But what the hell is this? It's a shoddy work? When I was welding for the first time in my life, it was with AC transformer, and the weld actually looked far better than this. Fluke doesn't have quality control or what? I'm not gonna pass any currents through this anymore, people, because this will fail before the fuse does. For sure. Don't they have quality control? Click. 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 Yeah, it's done. Now, the Fluke. It's there. So first, let's begin. In the middle, do we have the rubber? Yeah. Oh, was it a click? I hope. Oh, let's hope it was a click. It wasn't. Fuck this. Yeah. Another one. It's better to begin at the center because of the flex of the chassis. Let's hope for click. There are no clicks. Come on, please. Just one click. Let's push it in. Nothing. So just randomly I have hit the thread. Yeah. But randomly, unfortunately. Another screw. Let's try it. No. Yeah, it was a click. No, we are not in the thread. Why the hell do these Flukes come broken from the factory? Yeah, click. Ha, nice. So the second well hit thread. No, it wasn't click. Oh my god. No, please God, no. I hope to hit the thread at least with the last one. Nothing. God help me. Hey, I have hit the thread. God has helped me. Yeah. So, 3 out of 6 screws are bad. Have bad threads. and the rest, 3 of them, they have hit the thread just right. But you could hear that you couldn't hear the clicks, and in the Hioki you could hear them very clearly where the thread begins, but not in the Fluke. So beware, do not open Flukes frequently. You will mill out the threads in them. The Hioki was significantly easier to put together than the goddamned Fluke. So, to end the video, here we have Hioki DT4282 for approximately 550 euros or dollars including tax. Here is Fluke 87V Max for approx 940 euros or dollars including tax. So Hioki has one huge plus for the lower price, significantly lower price. Where Fluke is better is the warranty. The most expensive Flukes have lifetime warranty, which is at least 10 years. That's the minimum you get. Some cheaper Flukes have a 3-year warranty, and so does Hioki, a 3-year warranty. It's therefore comparable to exactly same price Flukes. If you would buy a Fluke for the same price as Hioki, you would get still 3 years. But we are comparing these two multimeters, and this one, as it's significantly more expensive, it also has at least 10 years of warranty. Service, that's where no one of them gets any point. Nothing. Hiokis must be sent to Japan for service and adjustments, so the overall price is almost the same as for a new multimeter. It just doesn't make sense. You would buy brand new this multimeter for the price of the adjustment. Fluke, at least here in Europe, has Blue Panther company to service their instruments, and man, stay away from them. If you are in Europe, just ask any manager from a competing company and they will have many stories for sure. Moreover, it takes eternity to have something serviced there, and the communication is almost non-existent. I have my experience with 3 more stupid instruments than this, much smaller. There are fortunately independent services, and these are much more better, but you can't put your multimeter in there if it's still in warranty. You will void the warranty. Package contents. Points for Fluke. You can buy Fluke in many different bundles to suit your needs. With Hioki, everything is sold separately, but at least you will get gold-plated leads. But still, Fluke wins in the package contents. Fluke is sturdier and will survive higher fall, and also is waterproof. Point for Fluke. Hioki is significantly more stable on the table, and it won't be constantly falling. Display. Hioki has a dual, Fluke has a bar graph. It's 50-50. Hioki is twice as accurate when it comes to DCV and also measures quicker and with more counts. Points for Hioki. When it comes to AC voltage, Hioki kills Fluke. Smarter RMS converter, better peak mode, 4 times wider bandwidth, 2 times as accurate, and it has decibels. Huge point for Hioki. High voltage indication, Hioki is the winner here. Fluke, you can just not notice the warning. Meanwhile, Hioki lets everyone in the room know about the presence of high voltage, even in dark. And we have currently reached currents. Hioki has significantly higher resolution, down to tens of nanoamps. To change a bad fuse, Hioki only needs you to unscrew 2 SLPH2 bolts, and that's all. Fluke must be taken out of its case, and then you need T10 Torx specialty bits to unscrew 6 bolts. Then you must find your lost batteries, and just after then you may change the fuses. When it comes to current safety, both multimeters have HRC fuses. Hioki has both standard 10.3 times 38 mm, while Fluke has the milliamp fuse slightly shorter. Here we have no winner. They are both equally good. No, what should not happen is the fact that Fluke's current shunt is a shoddy job and shouldn't have passed the quality control. Continuity test. Fluke is so silent that it has hard time overbeeping classic industrial background noise. And forget about checking your continuity near some running machines. Fluke's continuity check is useless, and Fluke receives -point for this. Hioki has one of the loudest buzzers I have ever heard buzzing, and moreover it has red backlight, so secondary indication. And we can also set the threshold, so huge point for Hioki. Diode test. Hioki has high enough voltage for any white LED if it's one in series, so great for servicemen. Hioki also allows to set the threshold for beeping. Fluke has just 2.4 volts, 2 volts less than Hioki, and not enough even for a white, blue or UV LED. Moreover, the indication of connected diode is one short and silent beep. And that's all. Battery power. 1 point for Fluke for the insanely low power consumption. It's so low that I wouldn't even believe it if I didn't measure it 5 times in a row. Yeah, it's really energy efficient multimeter. Point for Fluke. And 1 point also for Hioki, for the capacity indicator, for the APS indication, and for latching battery low warning. It's not common today. I have spent like 2 months preparing the review, as I wanted it to be as thorough as possible while keeping it as short as it's acceptable for one video. It won't be short, I believe. So I would present to you everything that may interest you and everything you would need to know when deciding between, for example, Fluke 87V series, not necessarily the Max, and Hioki DT4282 multimeter, and maybe also some other multimeters. As right now, the Hioki has seen its functionality being far superior to the ones of the Fluke 87 series. I think there may appear some comments under the video. Most of the comments would be thanks for the review, at least I hope so. But some comments are also gonna be mean to me and trying to mock me for Fluke not being the holy grail. And these people would call me a heretic cause I didn't pray to Fluke. So I have written down some of the most repeating and meaningful comments from Czech Fluke fans, or most fanatics more than fans, and I'm gonna answer them right now in advance before they are even written under this video. And I hope that these clarifications would make the comment section cleaner and much better environment for more technical arguments than just mocking someone because their favorite one didn't win. Now some arguments. You may as well end the video here and just head to the comments or anything, but if you have something on your mind, then you should keep listening. In my personal opinion, buying a Fluke 87 series only makes sense if you are a granddad or a great-granddad and don't want to learn anything new. It could be also taught about analog multimeters or instruments. Right above my head, if you were raised on these and don't want no change, then yeah, analog instruments or Fluke 87 series, they are good for you. You have been pressing the select button on the left and don't want to learn that the select button is on the right. That's one valid argument to buy Fluke 87 series. It's not valid. I'm just making fun. But if you require an instrument that is great in every fundamental aspect and that is actually comfortable to work with, Hioki is the winner. Clear winner. It's just better in everything that we users, multimeter users, we technicians and DIY hobbyists and everyone, what we crave for. We electricians and technicians, we have our desires for a fast multimeter, fast auto-ranging, fast acquire, fast and clear and loud beep, secondary visual indication, higher test voltage for diodes so we can service some backlight or we can service some room lighting or anything. And we also wish for a multimeter that stands on the desk stably and with confidence. Fluke, one of the most expensive instruments out there, doesn't have a clear beep, doesn't have a secondary indication, just nothing. We haven't moved in 30 years. Heck, 36 years. And there is also more. There is like decibels, there is current loop in percents, there is adjustable resistance and adjustable diode threshold. These are just nice extras that come with the fact that the multimeter belongs to the high-end category. There is also sometimes an argument that some state-owned agencies just don't want to change what works. Well, yeah, this is the number one rule if you are a technician. Don't stick your screwdriver in what's not broken. But on the other hand, let me tell you a story about the brand that made these instruments. In 1911, in Austria-Hungary, Erich Ročka founded this factory for electric measurement instruments. When the Second World War ended, communists took the factory from the owner as they usually do. Then they renamed the factory to Metra Blansko. At first the products were okay, and Metra being the only such a company in Czechoslovakia, it didn't have to fight for customers. It wasn't forced to become better. Long story short, Metra was the only company receiving state contracts, and as they had the place granted, they weren't evolving. This Avomet was their main sort of multimeter from 1956 to late 1980s. When all the major brands began making the very first digital multimeters in 1970s, Metra Blansko was still producing Avomets, and these analogs you see there, mostly these ones. In the 1980s, when digitals were becoming common, Metra was still producing these. It was the second half of 1980s when Metra decided for something new. Back then, Fluke, Sanwa, Yokogawa and some other brands that have disappeared, they all were producing classic style digital multimeters just like what we use today. And at this time, Metra came with PU500, another analog, but shitty this time. They also began production of their digital variant PU510, but that was too obsolete. It was garbage. Even this one is garbage. 2.5% accuracy, that's garbage. This one is 1.0% accuracy. So, in 1990, they had a multimeter the rest of the world had already in 1970, or before 1970. Until the fall of communism, they didn't bother. They got the state contracts, and that's that. When communism fell, they are in trouble. Today, Metra Blansko still exists, but their only customer is state-owned companies. And Metra supplies them with what? They supplied them with these analog meters. Just like this one. And see these two digitals there? Actually, I can take one of them down. The double one is really old. These multimeters also came from Czechoslovakia. They were made by a small group of enthusiasts, and they were great, even for the time. And we are talking 1970s, 1980s. But they didn't make it to mass production. Why? Only one company was allowed to make instruments, Metra Blansko. And state didn't want to hear about anybody else other than Metra Blansko with these analog bakelite instruments. When we already had these, and we already had this one. But no, state is state. State contracts, lack of concurrence, and commie stupidity was what prevented Metra, formerly Erich Hroučka company, from evolving. I have seen some state contracts, hell, I have even worked on one. They have nothing to do with common sense, and it's nowhere near the healthy capitalism we wanted. Just a bunch of tuxedo-wearing bureaucrat idiots who don't know shit about what they command, plus some corruption. That's that. Why did I tell you the story? So you will know how it ends if you work for something as stale and as stagnant as some of the state-controlled customers. You will find yourself standing in 1989 or 88 with freshly produced bakelite Avomet in your hand, brand new, while the rest of the world are already measuring digitally with auto-ranging and bar graphs. We could have the digitals, but state said no. State is a terrible regulator. Many people also claim that Flukes are superior in high voltage protection. Well, if it matters to you so much, get a Breiman, period. Moreover, all these multimeters are tested by independent laboratories for their Cat 4 600 volt in this case rating. So that's the second argument. And third argument, where are you gonna get the surge voltage? At my first job, I have worked in a factory as electric maintenance technician / IT guy, and we only got a shitty manual. It was the lowest end multimeter that could be at least turned on, and it was very similar to this one. Such a multimeter like this one. We had this multimeter and maintenance. And the multimeter has been working for many years in the factory. Factory full of CNCs and lasers and welders. Sometimes some monitors needed a recap, or computers needed a recap. I did it all. using this multimeter. I then worked in electric design office where I was drawing some schematics and harnesses for heavy diesel powered equipment, and there were also no problems with surge. There was nowhere to get the surge. And now I'm producing and servicing electrical cabinets, either full of technology like PLCs and VFDs, and also power factor correction cabinets. As such, and again, I have never met voltage higher than 400 volts. Well, actually some production lines use 690 volts, but there is a closed system mostly maintained by the technicians from the company that made the line. So maximum you would probe around in Europe is 400 volts. What's the point? Most of the industrial multimeters won't even meet high enough voltage to trigger the surge protection in them. And if it happens, it's either the worker's fault, as he shouldn't have climbed on the 35 kilovolt power lines, or it was caused by lightning. And apart from that multimeter, there is also some dead workers and burning cabinets and exploded power factor correction capacitors and such. And one dead multimeter is nothing compared to the other losses. So yeah, high voltage protection is nice to have. But there are many other things that matter, and many of them have significantly greater influence on your safety than just a tiny hair-like narrow difference in HV protection. It's no game changer. For example, Fluke T10 and T50 series voltage testers. Many of these are faulty. They simply won't indicate presence of voltage because of design error. Fluke was actually forced to solve it because people were returning them to repair by hundreds. So Fluke has said that some range of series numbers are recalled and fixed. Nope. Even newer testers have the same problem. They won't indicate voltage presence. First option, they never fixed it. Second option, they just gave random numbers just for us to shut up. This is no serious behavior. There is also another claim. Flukes are generally very sturdy, and I agree, they indeed are. Even my Fluke 17B Plus has the sturdy feel. But well, look in my toolbox. You can see my $25 clamp meter in there. It has fallen many times on concrete, and tools that I throw in my toolbox usually land on this multimeter. And nothing. Oh, I had to change the test leads because I broke the previous ones. But test leads are more or less consumable item in this field of use. But if I would get an expensive clamp meter like Hioki CM4141-50, I wouldn't treat it like my 25 back clamp meter. I would carry it in a pouch. And that's the spirit. There are three types of people. Two of them treat their tools okay, and these are either responsible employees or self-employed folks who had to earn the money for their tools. And third sort of people is who treat their even expensive tools like shit, and they are usually also shit persons in their life, as they not even don't value other people's property that has been given to them, provided to them for free, but they also purposely damage the property to be the most feral Neanderthal around and win the respect of the other Neanderthals with IQ below 80. It's 2023, and today even the low ends are sturdy enough. Just look at these cheapos. They will definitely survive normally harsh conditions. Any sane person with common sense would not be able to destroy even average low-end multimeter. The era of brittle DT830s and brittle 3900s, it's long gone. This is not today. Some people were also saying that they would buy even in every way inferior Fluke multimeter, and that's just because Fluke makes good desktop multimeters and calibration equipment. Yes, it does. It's actually the only one in some fields. And these instruments, they are great. These calibrators, they are the only one, I believe, who makes calibrators for scopes. But this has nothing to do with this multimeter. This multimeter has nothing to do with oscilloscope calibrator. It's like you would buy a Volkswagen car just because you like the taste of Volkswagen sausages. Yes, Volkswagen actually produces sausages. Or you would decide to buy a Yamaha motorbike just because their pianos sound great. Or you would buy a Liebherr crane because they made good quality fridges. We actually had one Liebherr fridge and it's still working today. Good quality. So these are absolutely the same cases. Every product speaks for itself. and its own functionality describes its qualities, not the other products. Piano is no motorbike, sausage is not a car, fridge is no fucking crane, and just like multimeter is no oscilloscope calibrator. Absolutely different products, totally different production lines, totally different designers. They have nothing in common other than the yellow and the logo, just like the Volkswagen sausage and Volkswagen Golf. Some people also tend to refer to the Fluke legacy, how Fluke practically defined modern multimeters. Yes, Fluke used to be innovative, and back then the instruments were very well designed for convenience of use. But instead of keeping on making it even better, Fluke somehow stopped. Why pay extra money for something that used to be, but you wouldn't get it today? It may actually look like it, that I'm against expensive stuff. Not at all. For example, another brand considered industry standard, Tektronix. I like them. I have actually worked with one, quite a little older digital Tektronix, and I loved it. It was older, sure, it had limited modern functionality compared to the newer ovens we got there at the facility, but I always liked the Tex more. They were reliable, they were purely practical, their controls, that was pure logic. Everything was where it's supposed to be, and absolutely no bugs compared to the overly buggy ovens, where oven is described as bug hidden behind a bug. That's oven. But Tektronix, everything was done perfectly on them. That's how I imagine industry standard instrument. But Fluke multimeters, they are far from here. They do not deserve to be considered the industry standard. Not that you would say that Fluke is far better than Hioki because it's an industry standard. We have proven that Fluke has so many bugs and so many problems that it can't even be your classic multimeter for everyday use, even for non-professional use. If I would be buying a multimeter that would be earning me money, I wouldn't go for a Fluke because I know it would be driving me crazy and I would hate the multimeter. Just like I hate, for example, this amp probe. It may be made with great mechanical quality, but it's slow as fuck, and it eats 9-volt batteries like if you feed an ammo into a machine gun. When it comes to technical things, we must stick to critical thinking, skepticism, and don't take everything for granted, even if we are used to it. This is no place for personal feelings and beliefs. This is place for facts, and the facts were, I would say, well presented in this video review comparing two high-end multimeters. You are of course free to communicate and share your experience below in the comments, but please be polite and exact. As on my main Czech channel, my review has triggered, or the facts in the review has triggered 4 Fluke fanatics, and 3 of them resorted to write at me rude comments with lots of insults and offenses, yeah. Yet none of them didn't contain any factual arguments. They were just angry and with swollen vein on their forehead being red from high blood pressure, they wrote the comments that were the style of argumentum ad hominem, if you know what it means. So these were the 3 Fluke fanatics. The 4th Fluke fanatic, this time he just ignored everything that was in the video and he said, I will translate it freely, convenience and implementation of functions is what matters, and that's why I will always like Fluke. Yeah, like if this multimeter was convenient and well implemented. For 1/3 of the price, yes, it would be. But for the actual price it sold, hell no. Anyway, comment, like, share, whatever as you please, but please remain calm and factual. Just like fortunately 95% of people who commented on my Czech video or in the Facebook links and everything. And if you are deciding about disliking the video or not, rather write a comment. Present your argument rather than just slap one stupid button and leave without any feedback. I actually like feedback because with feedback I can make my videos better. I hope the review has helped you and that you learned something from it. Goodbye and see you in another video.